Okay, good morning, students. Today our topic is content addressable memory. What is content addressable memory? Content addressable memory is also known as CAM. Is also known as CAM. We already discussed various type of memories such as SRAM, DRAM, RAM, etc. RAM is volatile memory, and on the basis of the component that is used to build the memory cell, RAM is divided into two types, SRAM and DRAM. In SRAM cell, we use memory component such as flip-flops, etc. for making the memory. But but in DRAM, we use transistor along with a capacitor to frame a memory cell. In this type of memory, we can do both operation. That means we can do read operation as well as we also perform the write operation in this type of memory. And this type of memory is also independent to the location of is also independent to the location of extracting the data from the cell. It means that we can access any cell inside the memory. It is independent to the location of memory to which we want to access. We can access randomly any type of memory cell. We can access any location in the memory cell. That's why it is known as random access memory. Okay, so when I want to read some data from that type of memory, so for the reading process, some address of memory cell is required through which we can access the data that is written inside the memory cell. Okay, so this content addressable memory is somehow different from these RAM cells or these SRAM and DRAM memory, because in this type of content addressable memory, the input of the memory cell is not the address. In this type of content addressable memory, the input of memory cell is the data. You can easily understand this content addressable memory by using this block diagram. Some black block is present here. It is known as CAM memory array. The input of this CAM memory array is the data, and the output of this CAM memory array is match. You can say in broad way, you can say the input of this type of memory is the data, and the output of this type of memory is the address. But in other type of memories, input is in the form of address and output is in the form of data. So this one is the difference between this CAM memory. In this CAM memory, input is always in the form of data, and the output is always in the form of address. But in other type of memory, input is the address and output is the data. So this one is the major difference between this CAM memory and other memories. In other memory, first we provide the address, and after it, the memory cell search the address and find out the data which is stored in that particular address. But in this type of CAM memory cell, first we provide the data, and by using this data, some keywords word is extracted, and by using these keywords, find out the keywords, find out the data that is already stored in this memory. I am repeating my sentence. In this CAM memory, first we provide the data, then this by using this data, some keyword is extracted, and find out the keyword, and find out those keyword is there is in data memory cell or not. If the keyword in the data, or we can say in broad prospect, we can say if the data is present in the cell, if the data is present in the cell, so at that time the output of these at that time the output of this CAM memory cell is match signal. It means that if the data is present in the memory cell, at that time the signal that is provided, the output of CAM memory cell, that is match signal, is equal to 1. And if the data that is provided in the CAM memory cell is not available in the CAM memory cell, so at that time this match signal will be 0. Okay, I'm repeating my sentence. If the data that is to be searched is available in the CAM memory cell, so match signal is active. If the data that is to be searched is not available in the CAM memory cell, at that time this match signal will be low. Okay, this match signal is nothing but a address. Okay, so now this match signal is provided in the now this match signal is provided as an input. This match signal is nothing but a RAM word line. This match signal is nothing but a RAM word line. Okay, now this RAM word line is provided to a RAM memory cell. Okay, it means that this this match line, that is the combination of 1 and 0, uh, that is the combination of 1 and 0, makes some address, and this address is try to be searched in this RAM memory cell, and the data that is available in the RAM memory cell is provided as a data output. Okay, so this one is all about, the theoretical portion. This one is all about the theoretical portion of this cam memory cell. Okay, so we can also implement the this memory cell, this cam memory array. We can also implement this cam memory array by using this CMOS structure. We can also understand this cam memory cell, cam memory array, cam addressable memory by using this CMOS structure. Here we can say 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8 9. Here here 9 transistors are connected to frame a cam cell. Before this topic, we already discussed the RAM memory, and in that portion we studied about how read operation is performed in RAM cell, how write operation is performed in RAM cell. The same feature is also available in the CAM memory, because the upper portion of this circuit, that means this portion, the upper portion of this CAM memory cell is same as the RAM memory cell. Only the difference between CAM memory and RAM memory is the addition of this N1, N2 and this N3 transistor. This N1, N2 and N3 transistor is the only difference between CAM memory cell and RAM memory cell. Okay, here two transistors are present, this one and this one. These transistors are known as access transistor. These transistors are known as access transistor. The combination of PMOS and NMOS making a inverter. The combination of the upper PMOS and lower NMOS making a inverter, same as Here one PMOS is connected in the upper side, one NMOS is connected into lower side, and this combination is making a resistor. This combination is making a inverter. So for making a CAM memory, we need two inverters. One is connected this side, one is connected this side, and the output of this inverter is provided as an input of this inverter, and output of this inverter is provided as a input of this inverter. Okay, but the output of first inverter is also provided as an input of this N1 transistor, same as the output of this second inverter is provided as an input to this N2 transistor. Okay, now the combination of this, now the combination of two inverters along with the access transistor and the N1 and 2 makes a resistor, makes a gate known as XOR gate, makes a gate known as XOR gate. Okay, now how it works, now how it works. suppose 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 the input of the CAM memory, suppose I am making a black box, this one is the C. Suppose the input of the CAM memory is matched, suppose the input of the CAM memory, that is the data, is matched with the content that is already stored in the CAM memory. So at that time its output signal, that is match signal, will be 1. Okay, it means that I am comparing the input of the data, I am comparing the input of the CAM memory and the data that is stored in the memory, and according to it the output of the CAM memory is provided. Okay, so for this purpose, we need we need a gate that is used for the matching of two input, and we already know that for the matching of two input we always use a gate known as XOR gate. And for the matching property, XOR gate is also known as anti-coincidence detector gate. XOR gate is known as anti-coincidence detector gate. If I am making a truth table, if I am making a truth table of XOR gate, then in the two input XOR gate there are the 4 input combination, and according to these 4 combination we will get the 4 different output combination, 4 different outputs value. And in XOR gate, when both inputs are unequal, when both inputs are different, so at that time the output will be 1, and when the both inputs are 0, so at that time the output will be 0. And for because of this property of XOR gate is also known as coincidence detector gate. Okay, so suppose when the input of the CAM memory and the data that is stored in the CAM memory is not matched, so it means that this one input is the input provided to the CAM memory, and the other one is the data that is stored in the CAM memory. So if these both inputs are not equal, if these both values are not equal, so it means that at that time the output of this XOR gate will be 1. Okay, so it means that, so when the data is not matched with the data that is stored in the CAM memory, so at that time the output of this XOR gate is we will get the output of this XOR gate from this from the combination of this N1 and N2 along with these whole structure. So when the output is 1, so at that time this N1 will be in the saturation region. So when if the N1 will be in the saturation region, so this match signal will be in the 0. So this match signal will be, at that time the value of match signal will be 0. Means that if the data that is provided in the CAM cell is not matched with the content that is already stored in the CAM cell, so at that time the match signal will be 0. And when the input of this CAM memory, if the input of this CAM memory and the data that is stored in the CAM memory is matched, so at that time the matched signal will be active. Okay, suppose we are considering the first and last condition. Here both inputs are 0 and here both inputs are 1. It means that the data that is provided and the data that is already stored, if these both data are matched, so at the time the output will be 0. Okay, so if the output will be 0, so if the output will be 0, so at that time this n1 n3 transistor will be in the cutoff region, and the output of match signal will be 1. Okay, so it means that it suggests that if the input is matched, so if the input is matched with the content that is stored, so a match signal will be active, and in the other case the match signal will be not active. Okay, so this one is the CMOS structure. So this one is the CMOS structure of CAM cell. You can say for making a CAM cell you need nine different transistors. You need nine different transistor in which in which two PMOS are there, and seven NMOS are there. Okay, and there are bit line is present, and here bit line and the word line is present, and we already know that for the when bit line and word line are connected with each other, suppose vertical lines are bit line and horizontal lines are word line, and we know that when bit line and word line are connected with each other, so at that time the combination of this bit line and word line is making a cell known as CAM memory cell. Okay, so if I implement this CAM memory, here this square block is the CAM memory cell, here this square block is the CAM memory cell. So if I implement this CAM memory cell with the RAM memory, with the RAM memory cell, so that its overall structure, so that its overall structure will be look like, so this, so its overall structure will be look like. Okay, here the here this AND gate is used to provide a word line, and the vertical lines is the bit line. Vertical lines that is connected with the cam cell is the bit line, and the horizontal line that is connected with the cam cell is known as uh, word line. Vertical line is bit line, horizontal line is word line. So the combination is and word line and bit line, so the combination of word line and bit line is making a cell. So this colored portion, this colored square block, all these square blocks are CAM memory cell. It is also mentioned here, these all are the CAM memory cell. These all are the CAM memory cell. Here PMOS is present here, here PMOS is present here, and it is connected with a matched precharge, and it is connected with a matched precharge, and also the drain portion of each PMOS is connected with a is connected serially with a row of CAM memory cell. Here you can see the drain portion of each PMOS is connected horizontally with the drain of each row. Okay, so when all inputs are 0, so when all inputs are so when word line are 0, when all word lines are 0, or when all word cell lines are 0, and match signal is 1, when all word line are 0 and match signal is 1, match signal is 1, it means that the data that is stored in the CAM memory cell is also 0. So only at that time this match signal will be only at that time this match signal will be active. So suppose I am considering this match signal will be active, so if the match signal is active, I am explaining again, if this match signal is active, if match signal is active, so if match signal is active, if match signal is active, so at that time, if this match signal is active, so at that time, this one is at that time, so this one is in the short circuit position. So if this one is in the short circuit position, so this NMOS will be in the cutoff region. So if this NMOS will be in the cutoff region, so if this NMOS will be in the cutoff region, so that we can say the output of all the match will be 0. So that we can say the output of all match will be the 0, M0, M1, M2, M3, all will be the 0. Okay, this portion is already this portion is also represented here, this portion is also represented here. Each match line, that is match 3 to 0, remains high if the data in the row matches the data placed on the bit line. Okay, it means that when the data that is provided in the camp cell is matched with the data that is stored in the camp cell, so at that time this match signal will be one. And when this match signal will be one, so at that time this matched precharge signal will be one. So if this matched precharge signal will be one, so that we can say, so we can say the match 0, match 1, match 2, match 3 remains high. Okay, we can say if the data is matched, so at that time this match 0, match 1, match 2, match 3, these all will be 1. And if the data is not matched, so at that time these m0, m1, m2, m3 will be 0. Okay, so this one is all about the CAM memory cell. I hope you all students